Hey everybody, welcome to another con support video. This one's on converting repeating decimals to fractions. So if anyone needs help out there on this, let me help you out. So if we look at the console here, it's repeating decimals to fractions. I'm just going to click start for that one. And can I keep the con on the right hand side here, and I'll work on the Cami on the left. And then I'm going to try to upload the Cami as well, so you'll have that PDF to look at. Okay. So let's go through it. The first one says rewrite as a simplified fraction. Let me zoom in there so you guys can read that a little bigger. There we go. Let's see if that helps. Let me move my little face so that my face is not blocking the problems. Let's check. Okay, there we go. We can check it now. Perfect. Let's see how this works. So over here we've got 0.1 repeating. This is actually a really easy one. So if you're looking at the first problem, let me change that. It's a text box. We don't have a text box. Let's do the writing. Okay. So the first problem says, move this over a little bit. Okay. 0.1 repeating. So when you have 0.1 repeating, that's the same as you guys know 0.111111 forever and ever and ever. There's the shortcut we talked about, which is you just look at this and you say, all right, what place value does this end in? It ends in the 10th place. So if it ends in the 10th place, you're going to put it not over 10, but over 1 less than 10. So it's going to be over 9. And the 1, the numerator, is going to be the repeating element. So you just take that repeating element, becomes the numerator. So it'll be 1/9. Okay? And then you can always test it out, see if it works. So if you did 1 divided by 9 on a calculator, you would see that it is going to work. And then you can put it in, 1/9. That's a really easy one, right? So if the repeating element ends in the 10th place, you can just put it over 9. If the repeating element ends in the 100th place, put it over 99. Those are very easy ones. The reason that works, by the way, the algebraic justification for that is what Khan explained in his video. And you can see that if you were to, let's say, let x equal the repeating element, 0.1 repeating, then you could say that 10x is going to be equal to 10 times this, which would be 1.1 repeating. And then you can subtract 10x, take away 1x, and that's the same as saying, if you look at what they're equal to, that is exactly the same as 1.1 repeating, take away 0.1 repeating. And so the repeating element goes away. So what you're left with there is 9x is equal to just the 1. And so now when you divide by 9 both sides to solve for x, you get the value of 1/9, which is equivalent to 0.1, right? So this is the algebraic justification for the answer. But whether you do it at the algebra or the shortcut I showed you, it's going to get the same answer. The algebra shows you why it's over 9. But remember, if it's a repeating element that ends in the 10th place, you can just put it over 9. The repeating element becomes the numerator, and then the denominator becomes 9. So let's look at the next one. All right, this one says 0.16 repeating with just the 6 repeating. So this is a little trickier, right? So let me do this as number 2. So number 2 here is 0.16 with the 6 repeating, okay? So that's the problem we're focused on. And in this particular problem here, because the 1 isn't repeating, you can't just put it over 99. That's not going to work. So I think there's 2 ways to approach this. You can approach it algebraically, or you can approach it just with an intuitive sense of going with what you know already and using it. So I'm going to do it the first way, which is just like intuitively. So if you're doing it intuitively, you go, all right, let me change that to pink. So what's the fixed amount here? We can see that value is 1/10, right? We know that that amount is 1/10. So I'm going to write that pink value as 1/10. That's easy. What are we adding to that? This repeating element. Well, what is the repeating element? The repeating element is 0.06 with a bar just over the 6, right? So 0.06666666 forever. Now, you guys know how to write 0.6 repeating, because 0.6 repeating is just going to be 6 over 9, right? That's easy. What would you have to do to turn this green thing into this blue thing? Well, you'd have to divide it by 10. In other words, you have to move the decimal one place to the left. So if you divided this by 10, you would get this blue thing over here. So we know how to write this. This is just 6/9. So that means the blue thing can be written as the 6/9 divided by 10, and dividing by 10 is the same as multiplying by 1/10. So now we can think of that as just 6/90, right? So now when we put it together, we'll have the answer. So we got this pink thing, which is 1/10. We're going to be adding that 1/10 to the 6/90ths. So let's make a common denominator. 1/10 is the same as 9/90ths. So now you got 9/90ths, and you're adding to that the 6/90ths. And so your actual value would be 15/90ths. And hopefully you guys recognize that 15 goes into 90, so you can divide top and bottom by 15. And let me write that out a little bit more carefully for you guys. And you're going to get the answer of 1/6. So this one's actually worth 1/6. So if you were to put 1/6, you're going to get that right. And you can do it algebraically as well. So let me show you algebraically how Khan Academy would do it. So they would say, okay, let x equal 0.16 with a 6 repeating. Okay? Because there's one place that's repeating there, we're going to times it by 10. So they'll say then, okay, then 10x would be equal to, shift the decimal one to the right, 1.6 repeating, right? So then they would say, okay, let's do 10x, take away 1x, and that's equal to 1.66 repeating, basically. Take away 0.16 repeating. And when you do this problem here, just to show you what it looks like, 10x minus 1x is 9x, right? But this element over here, that would be 1.66 forever, and then taking away from that 0.16 forever. And you want to make sure that the repeating element's on top of itself, right? Which it is. And now you can just subtract. That's going to go away, and you're going to be left with 6 take away 1, which is 5, and then 1 take away 0, which is 1. So you're going to end up with 1.5. So then ultimately what you have here is you end up with 9x is equal to 1.5. You want to undo times by 9, so you divide by 9 both sides. When you're solving an equation, as long as you do the same operation on both sides, you're going to get an equivalent equation, the same solution. So now what we have here is 1x is equal to 1.5 over 9. And 1.5 over 9 is the same as times top and bottom by 10, 15 over 90 like we saw before, which is the same as divide top and bottom by 15, 1 over 6. Okay, so you can do it the Khan Academy way, or you can do it the way I showed you in class. Now, I like the intuitive way a little bit more because it's just like, okay, what's the pink value worth? We're adding it to this repeating element. And you can just use the stuff you already know to quickly identify what the repeating element would be. I like that method better. Can you do it algebraically? Yes, but I recommend using the method I showed you in class. Okay, so let's do the next one. Now that I've shown you both methods, I'm going to do this the most expedient way possible. Okay, so for this number 3 here, what we're going to do, let me zoom in a little bit so I can write a little bit easier, is you've got 3.2 repeating. Now, this is a really nice one because we don't need to worry about the 3. The 3 is a fixed element, so 3 is just 3, no big deal. The 0.2 repeating is what we need to worry about, so we're really going to add to that the 0.2 repeating. Now, we know what 0.2 repeating is. That ends in the tenths place. So you guys can see that the decimal is going to repeat in the tenths place. So if we use our shortcut, we know that's going to be, the numerator is going to be the repeating element, and the denominator is going to be 1 less than 10, or 9. So we can think of this as just 2 over 9. So really, the answer is very simple. It's just 3 and 2/9. So when you go over here, you put 3 space 2/9, and you're done. The next one is 2.3 repeating with just the 3 repeating. So let's do that one as an example here. So this would be 4, or number 4, I should say. And we have 2.3 with the 3 repeating. So once again, this is a mixed number. We know the 2 is just going to be the 2. What are we adding to it? 0.3 repeating. We know that 0.3 repeating ends in the tenths place. So that repeating pattern ends in the tenths place. So we're going to put it over 1 less than 10, or 9. So that means it's real simple. It's just the 3 as the numerator and the 9 is the denominator, or 3/9. And so our answer is going to be 2 and 3/9. Now, 2 and 3/9 is the same as 2 and 1/3 because you can divide top and bottom by 3. So you're going to get an equivalent ratio of 2 and 1/3. And so that's what we put in, 2 and 1/3. 2 space 1/3. All right, let's do the next one. The next one we have here is 0.2 repeating. Well, this one's super easy and simple because we can just use our pattern for this one. So when you are looking at this one, it's just going to be 0.2 repeating. That's going to be 2 in the ninth, well, 2 over 9 because it's going to be repeating in the tenths place. So what's 10 minus 1? 9. So this is going to be 2 over 9, right? And I can write it out for you again if you guys want me to write it out. So that would repeat in the tenths place. So that means that the 9 is going to be 1 less than 10 as the repeating element on the denominator. And then the numerator is just going to be the top. Okay. Now let's do the next one. This is easy, 2/9. /9. Let's do the next one. Okay, 0.7, another really easy one. So this is going to be exactly the same type of situation here, where you're just going to say 0.7 repeating. Where does the repeating pattern end? It ends in the tenths place. So you're going to have a denominator that's not 10, but 1 less than that, which is going to be 9. And so the numerator is the numerator, 7, that's the repeating element. And then the denominator is 1 less than 10. So it's just going to be 7/9. 7/9. And last but not least, another really easy one. We already did it up here, basically. So you can see that's just going to be 1/3. But I'm going to write it out because I want to make sure everyone sees the process. So 0.3 repeating. That's the same as what place value does this repeating element end in? The tenths place. And then we can say that this is the same as 3 on top and 9 on bottom because remember, whatever place value that ends in is going to be one less than that is going to be your denominator. And so then you divide top and bottom by 3 and you get 1/3. So your answer here should be 1/3, 1/3, and now you've done all the problems. So most of these were very, very easy. They had one hard one thrown in there for some reason. So this was the hard one. And there's the 2 ways to do the hard one, right? The way I showed you in class or the algebraic method, which is right here. Okay. Let's stop the video. And let's see where that is. Let's see. How do I stop the video? There we go.